Hi guys, it's Miss Jackson. I'm going to walk you through our second lesson on our electron configuration notes, and we're going to look at orbital diagrams. Now, orbital diagrams are going to look like this image here. They're going to show the electrons within the orbitals as arrows instead of just writing an electron configuration. That was in the first video. So what we need to do is we need to review a couple of things. If you look in your notes, you'll see that for every sublevel, okay, S, P, D, and F, okay, again, on your periodic table, these are the S blocks, these are the D, this is the D block, this is the P block, and this is the F block. For each one of those sublevels, there is a very specific number of orbitals that exist in that sublevel. And what we're going to do is we're going to represent our number of orbitals with either boxes like you see illustrated here, or with a simple line. And I'll show you that in just a moment. What we do is we start by writing an electron configuration. So down here at the bottom, I'm going to write the electron configuration for carbon. Okay, so if I start by writing the electron configuration for carbon right here, if I look at my periodic table, carbon is number 6, so I've got to come up with 6 electrons, and I start filling them in the lowest energy level. That's Aufbau's rule. They fill the lowest energy first, so my first electrons go into the first energy level. This is the S sublevel, and it holds 2 electrons. Then I finish the first level and I'm ready to start putting electrons on my second energy level. So energy level 2, this is the S block, and I put 2 electrons there. But carbon still has a few more, so we move across. We are still in the second energy level, but now I'm on the P sublevel, and carbon is 2 seats over, 2 boxes over, so he's 2p2. So his configuration, the way it would write from the periodic table, is 1s2, 2s2, 2p2. What we do with an orbital diagram is related to the configuration, but instead of writing the superscripts 2s here, here, and here, we're going to show those as an image of an arrow. So what I do is I start with the energy level 1s, and I look at my S sublevel, and it gets 1 orbital, so I give it 1 line. You could draw a box, but I usually draw lines. Then I do the same thing for 2s. Energy level 2, sublevel S. Because it is an S, it only has 1 orbital. And then I come to my P's. When I look at my chart, P sublevels have 3 orbitals. So I'm going to get 3 blanks for the P. And I'm going to 1, 2, and 3. The next thing that I need to do is I need to show my electrons in the orbitals themselves. Now, electrons will always enter with opposite spins. And the way that we show that is with an arrow facing up and an arrow facing down. So for my 1s for carbon, there are 2 arrows. So I put 1 pointing up and I put the other pointing down. 2s, I have 2 arrows, 1 points up, 1 points down. For the 2p, I'm going to go ahead and put in arrows, but there's a rule that you need to remember. The electrons are going to fill in 1 per blank until they have to pair. They want to have the most number of unpaired electrons, and so they don't partner up until they have to, until all the blanks are full. So for 2p, I'm going to put an up arrow on the first blank, and I'm going to put an up arrow on the second blank. And that would be the orbital notation for carbon. And all it is very similar to the configuration, but it's showing the electrons in the orbitals, but we show them as arrows, and we point them in opposite directions in the same blank. And then if we have multiple blanks on the sublevel, we put 1 arrow per blank before we double up. So let's take a look at the ones in your notes. All right, so the first one you have is for oxygen, who is right here, right? So there's oxygen. His electron configuration is 1s2, 2s2, 2p4. So just like for carbon, I'm going to draw one orbital for the 1s. I'm going to draw a single orbital for the 2s. Again, going back to my notes, the s sublevel only has one orbital. And then for the p, for 2p, I have 1, 2, 3, because the p sublevels all get 3. I usually put a bracket so that it's a reminder those 3 go together in the p. And then I simply put my arrows in to the blanks. So for the 1s, I've got up, down. For 2s, I have up and down. And then for 2p, I have to apply my rule, and I put 1 up, up, up. And because I've got to do 4, now I can go put 1 in the first blank pointing down. And that's how you do it. So take a minute, try the orbital notation for sodium, which is number 11 right here. Pause the video, put that on your paper, and then come back to see how that works out. Okay, so for sodium, sodium has 11 electrons. And so I write my configuration, 1s2, 2s2, 2p6, and then I have to come right down here and I am 3s1. So to show my orbital notation, for the 1s, I get a blank. For 2s, I get a blank. 2p gets 3 blanks because p sublevels have 3. And then I have another one on this configuration, or for this orbital diagram, for 3s. And then I go back and I put in the arrows. I have up, down. I've got 1, 2. In the p, I always practice 1, up, 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 and then I put them down, down, down. If you practice it that way, you won't forget on test day. Then the last one I need to add is in 3s. I put it right there, and I am finished. The reason we do this is so that we can ultimately see how many unpaired electrons there are, because unpaired electrons are going to be where bonds are formed. So your oxygen has 2 unpaired electrons, and oxygen will form 2 bonds. Okay. Your sodium has 1 unpaired electron, and that's going to impact how it bonds as well. So go ahead and practice your orbital diagrams on the last page of your notes and reach out if you have any questions. Thanks.